Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in today's class we are going to continue the chapter electricity, and I hope that today's class is going to be more interesting one than previous, because yesterday we finished the class with an interesting concept. Do you remember that? Yes, it is the resistance of a system of resistors. Then there we come across some of the interesting points. Let me tell you one by one. The very first one, why are resistors connected in different ways? Right? Then, if so, how they are to be connected? Then after connecting, how will be the movement of electrons? Then these electrons movement will be responsible for variation of the resistance, is it not? Yes. Now, just we shall go for recalling these interesting points. The very first one, why are resistors connected in different ways? Dear students, we know that every day we come across different electrical components, and these are having different electrical resistances also, and the amount of current drawn by them will be differ from one component to another component. So they cannot be connected in one particular path. The reason is the proper electric current will not flow. Right? This is one reason. And another reason is sometimes we need to increase the resistance of the entire circuit, and sometimes we have to decrease. So in order to get the desired electric resistance, maybe high or low, we will go for connecting them in different ways. These are the two reasons. Next, how they are to be connected. In order to satisfy these reasons, we will go for connecting them in three different ways. They are, one is series connection, second one is parallel connection, third one is mixed connection. Then after connecting, how will be the movement of electrons? And also a reason for this question. Now let us come to know. Before that, just to recall, when do you say the resistors are connected in series? Yes, if two or more resistors are connected end to end, then they are said to be connected in series, right? Then how will be the movement of electrons in case of series connection? Yesterday I had already shown you this chart. Now again I am going to show. Look here. Here the resistors are connected in series. The movement of the electrons, they oftenly get the obstruction for their movement. Hence electric resistance increases. Clear? When they are connected in series, electric resistance increases. Next, another point. When do you say the resistors are connected in parallel? If two or more resistors are connected between two same points, then they are said to be connected in parallel. Then how will be the movement of electrons? Here also, again I will show you the chart. Here three resistors are there, they are connected in parallel, and these are the electrons, and all these electrons will distribute to three parts. Hence there will be less obstruction for their movement. As a result of it, electric resistance decreases. Clear? Okay. And even we had come to know the circuit in which how the resistors are connected in series. In addition with that, some of the important points were also known to us. Now let us go for recalling them. See that here these are the three resistors R1, R2 and R3 which are connected in series. Now when they are connected in series, once the current is constituted in the circuit, the same amount of current flows through R1, R2 and R3. This is first point. And the effective resistance of the entire circuit can be written as Rs equal to R1 plus R2 plus R3, as we have taken three resistors here. And third important point is the potential difference across each resistor will be differ from 1 to 1. But when you go for adding all these potential differences, which will be equal to potential difference of a battery. Clear? Next, another one is when the resistors are connected in parallel, then the effective resistance or equivalent resistance can be written as 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Next, here once the electric current is constituted in the entire circuit and this current will be distributed to all the three resistors. Here, see that at the point A. Then the amount of current flows through each resistor will be differ from 1 to 1. Whereas potential difference is same because it is to be obtained by connecting voltmeter between two same points across each resistor. Hence potential difference across each resistor is equal to potential difference of battery. Clear? So this much was learned. Now let's go for continuing the next interesting part. Dear students, as we know that the resistors are to be connected in two different ways. One is series connection, second one is parallel connection. When the resistors are connected in series, then effective resistance increases. In parallel, the effective resistance decreases. And we have formula for those two also. Now, we are going to find out the effective resistance or total resistance, nothing but equivalent resistance or resultant resistance when the resistors are connected in series or as well as parallel. First, I am going to take the derivation with respect to series. Please don't copy, observe. It is very important in the examination point of view. You should also write this as a question. Okay. The question can be asked like this. With the help of a neat circuit diagram, derive the formula to calculate the equivalent resistance of three resistors. Here we have taken R1, R2 and R3 connected in series. This is the question. Then you have to draw the circuit diagram. This is the circuit diagram. You can observe that. Here three resistors are there, R1, R2 and R3. They are connected end to end, which what we say, it is series connection. Then thereby it is connected to terminals of a battery along with the switch and the ammeter, which measures electric current. Then we will go for finding the potential difference across each resistors. Just we have connected voltmeter. Now I am going to switch on. Then electric current start flowing from positive terminal to negative terminal of a battery. I am showing the direction. The amount of current constituted, I go for taking this as I. Then voltage across each resistor, you no need to go for taking 3 voltmeter, just 1 voltmeter across R1, you take the reading. Call it as V1. In the same way, V2 and V3. Clear? So after drawing this circuit diagram, you have to write the terms. Then what are those terms? Here I'll write. Consider R1, R2 and R3. What are these? These are the three resistors connected in series. Clear? Okay. Then what about V1? V1 is the voltage across R1. Here I'll write. V1 is voltage across R1. Then what about V2? V2 is the voltage across R2. Voltage across R2. Please don't go for using this ditto symbol. You have to write in sentence. Then V3 is voltage. V3 is voltage across R3. Clear? Next, what is V? V represent the voltage of a battery. Here I'll write. V is voltage of a battery. Then what about I? I is the amount of current constituted after connecting these three resistors in series. Here I'll write. I is current flows through R1, R2 and R3. We know that same amount of electric current flows through all the three resistors when they are connected in series. Right? Now, we all know that the potential difference across each resistor, that will be equal to voltage of the battery. Means the sum of voltage across each resistor is equal to voltage of the battery. I'll write that sentence. We know that the sum of potential difference across each resistor is equal to what it is? Equal to voltage of the battery. Then this can be written mathematically as V is equal to, that is voltage of the battery, which is equal to voltage across R1 plus voltage across R2 plus voltage across R3. Clear? You may call this as equation 1. Then we all know that according to Ohm's law, we can write R is equal to V by I. Let me go for solving V. The reason is we need to take substitution for V, V1, V2 and V3. Hence I am using Ohm's law. So V is equal to I into R. I call this as equation 2. As we know that once the electric current is constituted in the circuit, the same amount of electric current flows through R1, R2 and R3. I'll write that in case of series connection, the current or the same amount of current, that is I flows through what? R1, R2 and R3. R1, R2 and R3. If it is so, then what is the resistance of first resistor? And first R1. Then what is the voltage across R1? It is V1. Hence we can write again by Ohm's law. V1 is equal to, here V equal to I into R. V1 equal to I into R1, because same amount of current flows. I call this as equation 3. Then V2 equal to I into R2. You may call this as equation 4. Then voltage across R3 is V3 equal to I into R3. You may call this as equation 5. Now you just go for substituting equations 2, 3, 4 and 5 in 1. Alright. Substitute equations 2, 3, 4 and 5 in 1. Equation 1 is V equal to V1 plus V2 plus V3. What is V? V equal to I into R. Equal to. What is V1? It is I into R1. What is V2? I into R2. And what about V3? It is I into R3. Clear? Now observe here, in RHS we have I as common factor. Then remaining R1 plus R2 plus R3. Then I are equal to this much. I and I get cancelled. Now R is equal to then R1 plus R2 plus R3. Clear? Now I go for taking RS in place of R, because here we have connected the resistors in series. Hence the equivalent resistance is to be taken as RS. You will go for substituting RS in place of R. Then I will write RS equal to R1 plus R2 plus R3. Hence the equation is, or the formula is derived. Hence the equation is derived. Got it? So this is an important formula to be remembered. When the resistors are connected in series, then the equivalent resistance is equal to the sum of resistances of all the resistors. Here we have taken 3 resistors, hence it is R1 plus R2 plus R3. If you take 2 resistors, it will be R1 plus R2. If you take n number of resistors, then we will go for writing Rs equal to R1 plus R2 plus R3 and so on plus Rn. Clear? Dear students, repeatedly I have been reminding, this derivation is very important in the examination point of view, will be asked for 3 marks. Here circuit diagram is must, then you go for writing the terms. See that R1, R2 and R3 are the 3 resistors connected in series. That sentence should be written. Then you go for writing V1, what is V1, V2 and V3 with respect to R1, R2 and R3. Then V is the voltage, I is the current. After that, this is very important statement. The sum of potential difference across each resistor is equal to the voltage of the battery. You will write that equation. Here we have voltage, so you will go for finding voltage using Ohm's law. And this is also another important point. Same amount of electric current flows through all the 3 resistors. Then you will get other 3 equations. Total 5 equations are there. Substitute 2, 3, 4 and 5 in 1. You will get R is equal to R1 plus R2 plus R3. Okay. Please do practice. Now you may copy from there to here. Dear students, just go through the second derivation. This is also very important. Again I have put double star mark. Earlier we found out the formula to calculate the effective resistance when the resistors are connected in series. That was Rs equal to R1 plus R2 plus R3. But here we are moving to the parallel one. Just go through the given statement. With the help of a neat circuit diagram, derive the formula to calculate the equivalent resistance of 3 resistors R1, R2 and R3 connected in parallel. We know that the resistors are said to be connected in parallel if they are connected between 2 same points. Observe it. In this circuit, you can notice that X and Y are the 2 points. Between these 2 points only, we have connected these 3 resistors R1, R2 and R3. Hence, we can call them connected in series. Sorry, parallel. Clear? Okay. Next, after that, the free ends are connected to terminals of a battery along with the switch and ammeter. Next, voltmeter is connected between 2 points X and Y. Got it? So when you press the key, then the current starts flowing. That direction of flow of current is shown. So direction of current is shown from positive terminal to negative terminal of a battery. And see that here the current flowing through each resistor is also mentioned as I1, I2 and I3. And another point, we have already learned that, just I am reminding you, when the current comes to the point X, here it gets divided. And this divided current will flow through these resistors R1, R2 and R3. And that current is taken as, that is current flowing through R1 as I1, R2 as I2, R3 as I3. Then after that, again the recombine at point Y, then again they start flowing in the entire circuit. Clear? Then what will be the effective resistance of the entire circuit when the resistors are connected in parallel? Whether it increases or decreases? Obviously it decreases. Now let us go for deriving the formula to calculate effective resistance. Here I go for writing the terms. Nobody should copy, just you have to listen to me carefully. Here, what do you call R1, R2 and R3? These are the 3 resistors or 3 resistors. How they are connected? They are connected in parallel. 3 resistors connected in parallel. Next, what do you recall V. V is nothing but voltage of the battery. V is voltage of the battery. Next, what do you say about I1, I2 and I3? I1 is the current flowing through R1, I2 is the current flowing through R2 and I3 is the current flowing through R3. I write the same. I1 is the current flows through R1. Similarly, I2, but you have to write in sentence, but I am using the ditto symbol, through R2. Current flowing through R3 is taken as I3. I3 is the current flowing through R3. Understood? And we all know that the total amount of current flowing in the entire circuit is equal to the sum of current flowing through each resistor. Right? I go for taking I. What is I? I is the current. I is the current constituted in the circuit, flowing in the circuit. Then we can write the current I flowing in the circuit is equal to the sum of the current flowing through R1, R2 and R3. Here I will write the same. The current flowing through R1, the current flowing through R1, R2 and R3 is to be written as I1, I2 and I3. That has been already written here. Now, the current I flowing in the circuit is equal to what? Is equal to the sum of current flowing through each resistor. Is equal to the sum of current flowing through each resistor. Hence, we can write I is equal to I1 plus I2 plus I3. You may call it as equation 1. Clear? The current flowing in the entire circuit is equal to the current flowing through R1, R2 and R3. Then let us go for taking substitution for these. We need to take substitution for I1, I2 and I3. Hence, I go for using Ohm's law. By Ohm's law, how do you write? We know that R is equal to V by I. What about I? I is equal to V by R. You may call it as equation 2. And we all know that the potential difference across each resistor is same. That has been taken as V, which is equal to voltage of the battery. Potential difference across R1 is V, R2 is V, R3 is V. Potential difference across each resistor is same. Here alright. It is also very important point. We know that potential difference across each resistor is same. Hence, now we can write then the current flowing through the first resistor, that is I1, is equal to V by R1. Right? Call it as equation 3. Then the current flowing through second resistor is I2. I2 is equal to V by R2. Call it as 4. Current flowing through the third resistor is I3 is equal to V by R3. So we have written just V only because voltage across each resistor is same. That has been written here. Now let us go for taking substitution for equation 1 from 2, 3, 4 and 5. Here I will write substitute equations 2, 3, 4 and 5 in 1. Then how do you write equation 1? I. What is I? V by R. Then what is I1? It is V by R1. I2. It is V by R2. I3. It is V by R3. Clear up? Then you can observe that in the RHS, in the numerator, V is common. I go for taking V as common factor. What will remain? In the first term, 1 by R1. Second term, 1 by R2. Third term, 1 by R3. Clear up? In LHS, V by R is there. Now V and V get cancelled. So 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Clear up? Now as it is, the formula is to find out the equivalent resistance for the resistors connected in parallel. I take that equivalent resistance as Rp. That is here I write R is equal to Rp. Now I write 1 by Rp, equivalent resistance of resistors connected in parallel. It is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula. When the resistors are connected in parallel, then the reciprocal of equivalent resistance is equal to the sum of reciprocals of all the three resistors. Understood? Okay. Now we can write, hence the equation is derived. I hope that you all have understood this. Now, here you have to copy from here to there. First you copy the question. Circuit diagram is very important with terminals and direction of current. And second important, the terms, what all the terms we have used there, they are to be written. Next, two reasons are very important. One is, that is, the current flowing in the circuit is, the current constituted in the circuit or flowing in the entire circuit is equal to the sum of the current flowing through each resistor. Then you will get this equation, use the Ohm's law, and we need to take substitution for all these. And we know that voltage across each resistor is same as they are connected between two same points. You will get three more equations, then substitute these four equations in the first equation. Then you will get 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So please copy from there to here. Dear students, now we will move on to some of the important numerical problems with respect to both series and parallel. Now first I am going to take very simple problem. Then we will move on to some other more important type of problems. Look at here I have written numerical problems. In that very first one, find the equivalent resistance when the following are connected in series. Got it? And here they are given the resistors and these are connected in series. If it is so, you are going to find out the total resistance, nothing but equivalent resistance. I go for writing the solution for first one. Here how many resistors are there? 2. How they are connected? In series. Then what is the formula? You know that Rs is equal to R1 plus R2 because two resistors are connected in series. What is R1? You may call 200 ohm as R1. Then R2, it is 300. 200 plus 300, it is 500 ohm. Such a simple. It is the effective resistance. Then 3 resistors are given. 4 ohm, 9 ohm and 13 ohm. 3 resistors are given. You can write Rs equal to R1 plus R2 plus R3. You can write it directly, but for the sake of understanding, even I am writing the formula as well. You call it as R1, this as R2 and 13 ohm as R3. What is R1? 4 ohm. R2 9 ohm and R3 13 ohm. And 4 plus 9 13. 13 plus 13 it is 26. So effective resistance or equivalent resistance is 26 ohm. Next, let us come across some other. Look here. Here they have given the resistors having higher value. Hence they are expressed in exponential form. 10 raised to the power 2 and 10 raised to the power 5 is there. It is also very simple. Rs is equal to R1 plus R2 because two resistors and which are connected in series. It is equal to 10 raised to the power 2 plus 10 raised to the power 5. Can you guess the answer? Yes. How do you go for simplifying it? Don't go for adding 2 and 5. It is not 10 raised to the power 5. So you have to write it separately. What is 10 square? It is 100. 10 raised to the power 5. It is 1 after 5 zeros. That is 1 lakh. Now add this. Here I am writing. It is equal to, see that 1 lakh plus 100. 1 lakh 100. So 1 lakh 100. Whoa. This is the value. Clear? So these are the simple problems with respect to series connection. Now we will move on to parallel connection. Go through the question. Find the equivalent resistance when the following resistors are connected in parallel. For parallel connection we have a formula, that is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on up to 1 by Rn. Here in first case, that is in the first problem, they are given only two resistors. Hence we can take 3 ohm as R1 and 6 ohm as R2. Now I'll write 1 by Rp is equal to 1 by R1 plus 1 by R2. Now let us go for taking substitution. What is R1? 3. 1 by 3 plus 1 by R2 is 6. Go for taking LCM. What is the LCM of 3 and 6? It is 6. Then multiply LCM with the first term. 3 ones are 3 twos are 2 ones are 2. Multiply LCM with the second term. 6 and 6 get cancelled. 1. It's equal to 3 by 6. Which is equal to, here I am writing. You can cancel. 3 ones are 3 twos are. 1 by Rp is equal to 1 by 2. Followed? We want only Rp, equivalent resistance, when the resistors are connected in parallel. Hence I go for taking cross multiplication. See that? 2 into 1, 2. 1 into Rp, Rp. So Rp is equal to 2 ohm. This is the effective resistance. See that? Actually 3 ohm, 6 ohm. If they are connected in series, what would be the value of effective resistance? It will be 3 plus 6, 9. But here the resistors are connected in parallel. Hence, why we go for connecting it parallel? To decrease the resistance. See that? The effective resistance is just 2 ohm. Clear? Let's move on to another one. And before going to that, just let me tell you one thing. Even this formula can also be written directly. Only for the sake of information I am giving. Observe. 1 by Rp is equal to 1 by R1 plus 1 by R2. And here only you can go for taking LCM. R1 and R2. And this will be numerator R2 plus R1. Can be written as R1 plus R2. 1 by Rp. Then what is Rp? Go for cross multiplication. Rp is equal to R1 R2 by R1 plus R2. You can also use this formula to find out the value. If it is simple numbers, it will be easier to follow this method. Next, here 3 resistors are given. Observe. Hence, I can go for writing 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Clear? This is equal to, what is 1 by R1? R1 is 5 ohm, R2 is 4 ohm and R3 is 10 ohm. It is equal to, now let's go for simplifying by taking LCM. I'll write it later, this third one. LCM of 5, 4 and 10. You can write it directly. It will be 20, right? If not, you can go for using the working column. Here 5, 4, 10. 5 ones are 4 as it is, 5 twos are 2. 1 as it is, 2s are 1s are. 5 twos are 10, 10 ones are 10, 10 twos are 20, 20 ones are 20. Take LCM 20. Multiply this LCM with the first term. When you write here 20, 5 ones are 5 fours are, 4 ones are 4. Here multiply 20 to the second term. 4 ones are 4 fives are, 5 ones are 5. Multiply 20 to the third term. 10 ones are, 10 twos are, 2 ones are 2. It is equal to, add them. 4 plus 5, 9. 9 plus 2, 11. 11 by 20. So 1 by Rp is equal to 11 by 20. But we want only Rp. Rp is equal to, here cross multiply. Or else you can go for taking reciprocal. Rp equal to 20 by 11. This is equal to, divide 20 by 11. 11 ones are 11. 9 will remain. Put decimal, take 0. It becomes 90. 11 eights are 88. 2 will remain. It becomes 20. 11 ones are, again 11 eights are, 11 ones are, 11 eights are. You will get recurring. Clear? So now approximately it can be written as 1.82 ohm. This is approximate value. Got it? So this is the method of finding equivalent resistance of resistors when they are connected in series and when they are connected in parallel. And we have 2 more problems with respect to parallel connection. I go for writing that. First, you go for copying from here to there. There to here. Please copy quickly. Look here. I have taken third one and fourth one. Let us go for solving this. After this, we will go for other type of problems. Look here. Here, they have given the resistors. One is smaller value, just 1 ohm. And another one is greater value, 10 raised to the power 6. That means 10 lakh ohm. When they are connected in series, parallel, what will be the effective resistance? And they have given some question. You have to judge also. Judge means the least one is 1. After getting the equivalent resistance, you have to compare with this one, whether it is greater than 1 or lesser than 1. Let's go further. How many resistors are given? 2. You call it as R1, this as R2. As they are connected in parallel, you can write 1 by Rp is equal to 1 by R1 plus 1 by R2. It is equal to 1 by R1 is just 1. 1 by R2 is 10 raised to the power 6. What is 1 by 1? 1. 1 by 10 raised to the power 6. 10 raised to the power 6, as I said, it is how much? 10 lakh. 10 lakh. 1 after 6 zeros. It is equal to 1 plus. You can express that in decimal form. See that it is 0.0000001. Clear? Okay. Now go for adding. It will be 1.00000. 5 times 0 and 1 ohm. Got it? But see that here they have asked you to find out just Rp. But what we have done? We have just added. Hence it is better to go for simplifying by taking LCM. Got it? Now just observe here. Here I am going to rub this one I'll write the same 1 by 1 as it is plus 1 by 10 raised to the power 6, 1 after 6 zeros. Now let us take the LCM. Here I'll write the values. 1 more 10 raised to the power 3 and 10 raised to the power 6. What is the LCM? It is 10 lakh. 10 lakh. 1 after 6 0. Then multiply LCM with the first term. You will get again 10 lakh. 10 lakh. Plus multiply LCM with second term. You will get 1. Add these two. 10 lakh plus 1. It is 10 lakh 1. Clear? Divided by 10 lakh. Got it? If you are finding it again difficult, still I can go for simpler way as take the LCM 10 raised to the power 6, then multiply LCM with the first term, you will get 10 raised to the power 6 plus multiply LCM with the second term, you will get 1. I think you find it this method is easier. It is, what is 10 raised to the power 6? 1 after 6 zeros, 1, 2, 3, 4, 5, 6 plus 1. Then this is 10 raised to the power 6, 1 after again 6 zeros. Then go for adding, that's all. It is 10 lakh plus 1 is 10 lakh 1. Clear? Divided by, it is 10 lakh. It is 1 by Rp. But we want just Rp. Take the reciprocal. Or you can go for cross multiplying. So Rp is equal to, it will be 10 lakh divided by 10 lakh 1. See, the numerator is smaller than the denominator. Then what will be the resistance? Whether it will be lesser or more than 1 ohm. It will be less than 1 ohm. Clear? So these two are very important result. This is final answer and this is the judgment. After finding the value, you can go for judging that the value is less than the smaller value of the resistance. Now we will move on to another one. See that here 3 resistors are given. This is fourth one. 1 ohm, 10 raised to the power 3 ohm and 10 raised to the power 6 ohm. Let's go for finding the value of this. Here as they are given 3 resistors, you can go for writing 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Let us go for taking substitution. 1 by, what is R1? 1. R2, 10 raised to the power 3. R3, 10 raised to the power 6. Clear? Now you can go for taking LCM. What is the LCM of this? It will be 10 raised to the power 6. Got it? Then multiply 10 raised to the power 6 with the first term, 10 raised to the power 6. Second term, 10 raised to the power 3 is there. 10 into 10 raised to the power 6, it will be 10 raised to the power 3. Third one, 10 raised to the power 6 should be multiplied to the third term, get cancelled, you will get 1. This is equal to, now again you can go for the same, 10 raised to the power 6, that means 1 after 6 zeros. 10 cube, it is 1000, 1 after 3 0. Next 1, 10 raised to the power 6, 1 after 6 0. Then go for adding them. See that 10 lakh plus 1000 plus 1. 10 lakh 1001. Right? So 10 lakh 1001. 1001. On adding you will get this one. 10 lakh 1001 divided by, it is 10 lakh. This is 1 by Rp. But we want only Rp. Take the reciprocal. it is 10 lakh divided by 10 lakh 1001. Again, here also numerator is smaller than the denominator, hence it is less than 1. Rp is less than 1 ohm. Clear? So from again these examples we can conclude that the effective resistance will be smaller because the resistors are connected in parallel. Okay, and please do copy from there to here. Let's copy this. Observe the third type question. This is very interesting and also very simple one as well. Just go through that. What is the highest and the lowest resistance that can be secured by the combinations of 4 coils of resistances 4 ohm, 8 ohm, 12 ohm and 24 ohm? Dear students, you all know that how we have to connect the resistors to get highest value and how they are to be connected to get lowest value. Can you recall it? Yes, you are right. For getting highest value, we should connect them in series. For lowest value, we have to connect them in parallel. Here, let us go for answering one by one. Here I will write highest resistance is obtained by how? By connecting the resistors, by connecting in series. Directly I am writing. Clear? How many resistors are there? 4 are there. So I can write Rs is equal to R1 plus R2 plus R3 plus R4. Not necessary to write formula, you can write it directly. Again, only for the sake of understanding. R1, what is R1? 4 ohm. R2, 8 ohm. R3, 12 ohm. And R4, 24. It is equal to, what is 4 plus 8? 12. 12 plus 12? 24. 24 plus 24? 48 ohm. So Rs is equal to 48 ohm. Clear? That is the highest value. But how do you come to know that is only highest value? Then for the sake of comparison, you can go for answering second one. And we all know that lowest value is obtained when the resistors are connected in parallel. Here, lowest resistance is obtained by connecting the resistors in parallel. Let us come to know how this is. Again, here also, here I write Rp, reciprocal of Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4, because 4 resistors are there. It is equal to 1 by, what is R1? It is 4. 1 by R2, it is 8. 1 by R3, it is 12. 1 by R4, where R4 is 24. Then what is the LCM of all these? We know that they are all the multiples of 4. Then HCF will be 4, but we want LCM. LCM will be 24. If you do not know, please go for using working column to find out the LCM. Now, multiply LCM with each term. When you write here 24, 4 how much are? 4, how much are 24? 4 6 are 24, 6 ones are 6. Here, 4, 8 how much are? It is 3 are 3 ones are 3. Plus. Multiply here. 12 how much are 24? 2s are 2 ones are 2. Here multiply 24. 24 how much are 24? 1s are 1 ones are 1, which is equal to, add all these, 6 plus 3, 9, 9 plus 2, 11, 11 plus 1, 12, 12 by 24. This is equal to 1 by 2. Please don't go for writing 0.5, because we want Rp, but here we have reciprocal of Rp. 1 by Rp is equal to 1 by 2. Then take the reciprocal. Rp is equal to reciprocal of 1 by 2 is 2 by 1. It will be 2 ohm. See that lowest value 4, 8, 12, 24. See that Rp is just 2 ohm. Why? The reason is resistors are connected in parallel. Clear now? Yes. Now you have to copy from there to here. After this, I'll go for solving one more type of problem. Copy quickly. Dear students, fourth one, it is also very important one in the examination point of view. You can just put double star mark for this. And another one, it was also given in the examination already once. Next, it is very interesting. Why? Just you will come to know that. See that. Question is, how can three resistors of resistances 2 ohm, 3 ohm and 6 ohm be connected to give a total resistance of first one 11 ohm, second one 1 ohm, third one 4 ohm. Got it? Here they are asking you how you are going to connect the resistors to get these values. Earlier we used to find out the value, but now value has been given, but you are going to tell how they are to be connected. So we have to give the justification as well. See that here 11 ohm, that is highest one is there, right? 11 ohms, 1 ohm, 4 ohm. To get the highest value, how you are going to connect the resistors? Yes, you are right. They are to be connected in series. Now let us check it out. Look here. I'll go for answering one by one. Answer for first one. The resistors should be connected in series. Right? This is the answer for the given question. But you have to give justification. That means when the three resistors are connected in series, you should get 11 ohm. I'll write justification. How many resistors are there? 3 resistors. So I can write R is equal to R1 plus R2 plus R3. Here we have mentioned they should be connected in series. Hence we have written like this. What is R1? 2 ohm. What is R2? 3 ohm. What is R3? 6. It is equal to 2 plus 3 plus 6. How much it is? 2 plus 3 is 5. 5 plus 6 is 11. 11 ohm. Got it? Our answer is right. Next, let's go for answering second one. Answer for second question. 1 ohm. Among these, 1 ohm is the lowest. To get the lowest value of the resistance, how you are going to connect the resistors? Yes, it is. They should be connected in parallel. Already we have come to know that the different ways of connection with respect to resistors are to be done only to get the desired resistance. Either it may be high or it may be low resistance. To get high, series connection. To get low, parallel connection. Here let us go for connecting them in parallel. I'll write the same. The resistors should be connected. What do you write? In parallel. Very important one. Let us go for giving justification for your answer. Justification. Then here 3 resistors are there. We are going to connect them in parallel. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is equal to 1 by, what is R1? It is 2. R2, it is 3. R3, it is 6. Clear? Now, Let us go for taking LCM. What is the LCM? The LCM is 6. Multiply LCM with the first term. Here 2 3s are 3 1s are 3. Multiply 6 here. 3 2s are 2 1s are 2. Multiply 6 here. 6 1s are 1 1s are 1. It is equal to 3 plus 2 plus 1 6. 6 by 6 1. 1 by Rp is equal to 1. Cross multiply. 1 equal to Rp. Rp equal to 1 ohm. See that? To get the lowest one, that is 1 ohm, we have to connect the resistors in parallel. Next, another one is there. 4 ohm. Then, are you going to connect them in the series? When you connect them in series, you will get the value 11 ohm. In parallel, you will get the value 1 ohm. Then how we have to connect the 3 resistors to get the value 4 ohm? Yes. Let us go for that. Answer for C1. Dear students, we have 3 types of connections. Series connection, parallel connection and mixed connection. Just I am going to show you the chart. Observe here. Here there are 3 resistors, R1, R2 and R3. How R2 and R3 are connected? They are connected in parallel. So effective resistance, you call it as 1. Clear? Then this resistor and R1, how these are connected? Series. Got it? Series and parallel. It is a mixed combination or mixed connection. So here, if you want to get the value, it is not higher, neither highest nor lowest, in between. Hence, we can go for connecting them in the mixed connection. How? First, you may go for taking 2 and 3 as series, and after that, what value you will get, that will be connected to 6 ohm as parallel. Or you may go for taking 3 and 6, or you may go for taking 6 and 2, just by trial and error method. I go for doing one thing. Let us keep that 2 as it is. Then 3 and 6 ohm are there. You just connect them in parallel. Are you all understanding? I'll draw the circuit like this. See that? This is mixed connection. Here is 2 ohm, this is 3, this is 4. This is 6. The purpose is, here if you go for taking 6, it will be more. Understanding? We want value 4 only. Yeah, you cannot take 6 here. That is why I have taken 2. Now I go for connecting 3 and 6 in parallel. Let us find out the value of this. So 1 by Rp is equal to 1 by this is R2 and this is R3. R2 plus 1 by R3. It is equal to 1 by, what is R2? 3. 1 by R3, 6. It is equal to, LCM is 6. Multiply 3 2s are. Multiply 1s are. You will get 3 by 6. And it is 1 by 2. 1 by Rp is equal to 1 by 2. Then Rp is equal to 2 ohm, right? So this whole value, it is 2 ohm. And see that this is and this 2 ohm, how these are connected? They are connected in series. If they are connected in series, then we can go for using the formula. Rs is equal to, this is R1 plus this Rp. Rp. What is R1? 2 ohm. Rp? 2 ohm. It is 4 ohm. Clear? So, here I write, just once I write, see that. Rs is equal to R1 plus Rp, where R1 is 2, Rp is 2, this is 4 ohm. Got it? So, you got this value 4 ohm. Then how do you write the answer? So we have to write the answer that we can get the value of 4 ohm by connecting these resistors in parallel, in mixed connection. Then 3 and 6 should be connected in parallel and 2 should be connected in series, 2 ohm. Let me write by mixed connection. Clear? So for that, here for justification, we have shown the circuit as well. See that 2 ohm is connected in series with the parallel connections of 3 ohm and 6 ohm. Understood? So this is one of the important type of problem to be asked in the examination. Please do practice. Now, please copy from there to here. I hope that you have copied this, dear students. And today also we have come across many important problems. Please do practice all these problems today itself. Don't keep anything pending. Got it? Today we have solved the problems of both series connection as well as parallel connection, and one problem with respect to mixed connection. And in next class we have again some more numerical problems with respect to series and parallel connections by using circuit diagrams. They are also very interesting. Let us continue that in the next class. Thank you.